Hi everyone, this is Sam Gabriel. Welcome to another video. In today's video, I want to explore the Raft protocol that Vault and Consul relies on for leader election. And in today's video, I want to test and see if it's possible to run a Raft cluster over two availability zones. This has come up at a customer site before, and they had that question whether we can do that. And I'm going to test 7 nodes in a Vault Raft cluster and start to do some failovers and see what happens when we destroy the availability zone with the odd number or the one with the even number, and see how that all works. So let's dig in. All right, so let me draw this before you here and show you what I mean or what I'm trying to do. So let's say I have a, let's draw this line here, and I have availability zone 1, availability zone 2, and I'm trying to split a cluster, a Raft Vault cluster, over these two availability zones. So I'm going to try to put first of all, you know what, let's try this. If we do it like that, we know this won't work. If you put 2 here and 1 here, if you destroy the 2, that's not enough to maintain quorum for the cluster. If you destroy this one, that's also not enough to maintain quorum, so this doesn't work. So why don't we try this, 3 and 2. We know this won't work either, because if you destroy this availability zone, 2 are not enough. 2 nodes are not enough to maintain the cluster. If you destroy these 2, that's also questionable whether we'll be able to do it. Probably not. So let's do 7. The reason why I'm thinking about this is what happens if we destroy this availability zone. So if I go ahead and say availability zone 2 is down, so all of these Vault node clusters are down. Now I have only these 2. This AZ is available. So I got 4 nodes running here. This technically should work because I have a quorum. But in the other event, let's say I have AZ1 going down. So basically all of these nodes are down. Now the question is, I have a cluster, sorry, I have an availability zone with 3 active nodes, or 3 nodes that are running. Does this work? Will the cluster still be up and able to serve traffic? That's the question I'm trying to answer. So why don't you pause the video for a second and think about it for just a minute. Do you think that this cluster will work? Do you think that traffic will still be able to be serviced by the Vault cluster or not? Okay, so let's try it. Let's give it a try and see what happens. And I am going to demo that for you. So here I've got seven nodes. You can see Vault 1, 2, 3, 4, 5, 6, 7. 4 of which are in the West A availability zone, and 3 are in the B zone. This is all running in GCP, and this is a full Vault cluster. And we can test this. Let's jump into one of these. Just take this IP. Let's go in here. Okay, so this vault is sealed because I was just testing beforehand. So what we'll do is we'll go ahead and unseal all the vaults just before we start this experiment. Let's see what happens here. Seal status, the LTC connection refused. Let's see why this connection is refused. It's because I'm not on the node. I got kicked out. I probably got kicked out on all the nodes. So let me just SSH into these nodes. I'm already on these nodes. Okay, so this is fine. All right. Okay, so now I'm in the very first node. You can see Vault 1. Let's make it clearer. And check the status. Okay, so now let's export that and do that on all of my nodes, and I'm just cleaning this up. Really, you don't need to follow this. Just cleaning this up to get it ready for our experiments. Okay. Okay. All right, so what I have here at the top, I've got 7 terminal windows, 1, 2, 3, 4, 5, 6, 7, each one corresponding to one of the Vault nodes. The first one here is the one I'm going to run a few commands against, and basically I want to run the Vault operator. Actually, let me log in because I haven't logged in yet. So let me log in as root here, and let me run the command vault operator raft list peers. And this gives me the peers I have here. Okay, so I'm in Vault 1, and I can see that Vault 7 currently is the leader. Okay, so it doesn't matter. All the traffic gets forwarded over to the leader, even if I'm talking to this one here. All right, so the first thing we're going to do is we will destroy the B zone. So all 3 Vault nodes within the B zone, we're going to stop. So let's go back into our console. Actually, we can kind of log in here and show you the actual cluster. Let's make sure we're on port 8200. Okay. Okay, I'm signed in, and I'm signed in actually to Vault 1, which is a follower. It's not a leader, so traffic gets forwarded over to the leader. Not a big deal. You can see here's my KV store. I have a test secret, and it is key, foo, and value bar. So that's all working well. We are going to go and start to do some damage. We're going in here, and we're going to destroy the Vault nodes within the B zone, and we're going to stop those and see what happens. What do you think happens? Do you think that the Vault cluster will still be accessible and serve the secret that we have in there? Let's take a look. Okay, it's taking a few seconds here. But basically that's what we're going to do. We're going to stop these 3, see what happens, and then we're going to stop these 4 and then see what happens. Just simulating a zone failure. While this, oh, there we go, it stopped. So you can see these have stopped. Let's go back to our CLI here. Let's run this. Okay, so we can see that now the leader became Vault 1, which is the one we're on. Obviously it wasn't, it was Vault 7. We shut down Vault 7. It's no longer the leader. Let's go back to our UI and see if we're able to continue to access this cluster. Yep, it seems to be fine. We're able to still see our secret. We're able to navigate within the UI. The cluster is still good. No problems here. All right, let's now start these 3 instances again, and then what we'll do is we're going to stop the other zone, or stop all the Vault nodes in the other zone. So this is going to take a couple of seconds here. While this comes up, I still need to unseal these nodes. Remember, for this experiment, I'm just running Shamir. So that's why every time the node restarts, we need to go in and unseal those nodes. So we got kicked out of here, so let's get back into all these nodes. Okay, and let me just run the command to unseal. Okay, should be good. Let's just double check. Yeah, seal status is good. Let's clear this. Actually, before we clear, let's just keep it like that. All is good. There is also a way to see the Raft status in the UI. You can go here to Raft storage, and you'll see who the leader is and all the followers as well. Okay, so everything's good. We're back to normal. All the Vault nodes are up and running. Now what we're going to do is we're going to bring down all the nodes within the A zone and see what happens. And this is really the big questions the big question that we had. What happens when the 4 nodes go down? Technically, we still have 3 nodes. So from a leader voting election perspective, we have an odd number. So does the odd number that we have here available in the other zone, is that enough to allow us to have the Vault cluster up and running? Or the quorum is really dependent on the entire number of nodes within the cluster. So if we have 7, we have to have a quorum of 4. In this case, we have a quorum of 3. So which will it be? Having an odd number, is that sufficient to have the cluster running, or we have to have this 4 number? Let's refresh. All right, so this is down. Now let's go ahead and now that Vault 1 is down, I'm going to switch to Vault 7 and log in. Okay. Now let's do a Vault status, see if I'm in. Perfect. And now, the moment of truth. Vault operator Raft list peers, and no Raft cluster configuration found. Very interesting. So it seems like our cluster is down. Let's verify that, and let's try to go in through the UI to this node here, which is Vault 7, 8200. Let's see what that tells us. And there you go. This is a standby Vault node, but can't communicate with the active node via request forwarding. Sign it the active node to use the Vault UI. Basically, the cluster is hosed. We're completely down. Even if I try to use the root token to get in, we can't. We're completely down. So we've answered the question. You have to have a quorum of 4 in this case in a 7-node cluster. So the reality is, we really cannot split a Raft cluster over an even number of zones. So you can't really have a zone 1 and zone 2 and try to do that. Like I said before, I tried 1 and 2, 3 and 1 and 2, and then a 5, and then now a 7, right? So that doesn't work. And really, this was quite clear in the documentation here. If you go to this documentation here, I'll reference it in the description of this video. The consensus protocol, the Raft protocol. If you go to the bottom, this is a very nice table, which tells you if you have 1 server, then you have a quorum size of 1, and you have 0 tolerance. If you have 2, then you have 0 tolerance. So really, the minimum is 3. That gives you a quorum size of 2 and a failure tolerance of 1. So you can only afford to lose 1 node in a 3 server cluster. If we jump to 5, you see that you need a quorum of 3, and that gives you failure tolerance of 2. This is usually our recommended size when we're sizing Vault. It allows you to bring 1 node down for maintenance, and then the other node, if another node fails, then you're still okay. So it can sustain 2 failures. And then finally, the 7-node cluster. As you can see here, the quorum size is 4. You have to have 4 up at least. If you have less than that, your cluster is down. And looking at it from a different angle, the failure tolerance is 3. So basically, back to this drawing, you have to have a quorum of 4. If this zone goes down, the entire cluster goes down. So that doesn't work. So hopefully that sheds some light on the Raft protocol and the problem at hand that we cannot take the Raft protocol or any nodes in a Raft cluster and split that over an even number of zones. So the way to make this work is you need at least 3 zones for a high availability stretched cluster across these zones. Hopefully this has been helpful, and thank you for watching.